Welcome back. This is the second video in the explanation of a reduction oxidation reaction or a redox reaction. Often you need many times of explaining this before this makes sense because there's several concepts all working at the same time. So the last video that we had, I had this picture up of a pitcher and a catcher, and it's an analogy that I like to use of a redox reaction in which the baseball represents the electron. When a pitcher throws a negative electron, he's becoming more positive himself. He had something negative. When he got rid of it, he becomes less negative because he gave a negative away. By becoming less negative, that's the same as becoming more positive. He is oxidized. The catcher, as he's catching the ball, becomes more negative, and that's the idea of reduction. He's reducing his charge. He's becoming more negative. So it may be easy to understand that idea that whoever has the ball is reduced, whoever doesn't have the ball is oxidized. The harder concept is the idea that there's two players. There is the one who is becoming oxidized as he gets rid of the ball, the one who is reduced as he takes the ball. And each of these players not only have the name based upon whether or not they have the ball, they also have a designation as to what they're doing to the other player. So one more time, I'll go through this. I hope it helps you. When a pitcher throws a negative to the catcher, he not only becomes oxidized himself, but he's also the agent that's making the catcher become reduced. So we're going to call that the reducing agent. So the ion that becomes oxidized is also the agent that's making the other guy reduced. So the one who's oxidized is the reducing agent. Likewise, when the catcher catches the ball and becomes more negative, he becomes reduced because he becomes more negative, but he's also the agent that's making the pitcher become oxidized. He's removing that electron from the pitcher, and by doing that, he's oxidizing the pitcher. So the catcher is the oxidizing agent, and he's also being reduced. So let's look at this just a minute. This may help you, and I'd like you to copy this down. Even if you have to pause the tape and copy this down, I'd like you to do this. A reducing agent reduces other substances and loses electrons. Since an ox stole its electrons, it will become oxidized, and its oxidation number will increase. Let's look at an example of this. Sodium is in group 1. It's got one electron in its valence shell. And on the periodic table, element sodium is not positive or negative. It's neutral. It's got as many protons as it does electrons. But since it's in group 1, it has one electron in its outer shell. If another ion steals that electron, say like chlorine, if it steals its electron, sodium becomes oxidized because it has one fewer electron, and its oxidation number moves from 0 to positive 1, so it becomes more positive. So as it becomes oxidized, its oxidation number goes up. For every electron stolen, its oxidation goes up one from 0 in this case to positive 1. The other one, oxidizing agent, oxidizes another subject and gains electrons. So it's becoming reduced itself, so it's gaining electron, but it's oxidizing the other. So whatever's becoming reduced is oxidizing the other. Since it's the ox that stole someone's electrons, it becomes reduced, and its oxidation number will decrease. For example, chlorine's in group 7. Okay, so normally it's neutral, but if it steals an electron so that it can make its octet, like it steals sodium's electron, it becomes reduced and drops in charge. So it goes from chlorine to chlorine negative. So I hope this helps you.